Now we're going to be working with addition and subtraction of complex numbers, in fact with all the operations, but first we'll do addition and subtraction. Well, luckily we don't have to know anything new for these operations. For example, if we subtract minus 2 times the number minus 6 plus 5i, we have the same kind of situation as with numbers that we've worked with before. We have to worry about a couple things. One of them is that we have to worry about and so when we use the distributive property, we're going to distribute that negative 2 over this sum right here. So minus 2 times minus 6 is a plus 12. Minus 2 times 5i is a minus 10i. And at this point, in terms of combining these numbers, think about combining like terms. So the real part is combined and the imaginary part is combined. So 3 plus 12 is 15, I minus, and then we have a number in standard form. So for addition and subtraction, there's nothing new in terms of complex numbers. Let's consider now multiplication. We have to be a little bit careful about the way we multiply, but not any more so than with other numbers which multiplying two binomials together. And if you are used to working with the FOIL method, then you can use that. At any rate, every term has to be multiplied by every other term. So let's start out with a 3. 3 times negative 2 is a negative 6. Negative 5 times negative 2 is a plus 10i. 3 times 6i is a plus 18i. And then finally, negative 5 is a negative 30i squared. This is the one thing that you have to worry about. You're going to have an I squared term there when you multiply two numbers which have imaginary parts. Remember that I squared is equal to a negative 1. And so when we have a negative 30 times I squared, that's the same thing as a plus 30. So now we'll put the real parts together. Plus 30 I is a plus 28i. So this is the one part where you're going to have to be a little bit careful with. But another example, suppose we have simply an imaginary number which is just an imaginary number, such as 3i, and we multiply that by the number 2/3 plus 4i. The way that we have done it before, we'll use the distributive property, and so we'll have 3i times the number 2/3 plus 3i times the number 4i. Okay, when we multiply 3i times 2/3, just as we did before, we can go ahead and simplify by canceling the 3's. So we're left with 2i for the first part. For the second part, we have 12i squared. Now we're going to rewrite the I squared as a minus 1. So that's minus 1 times 12. That becomes a negative 12. And so we have 2i minus 12. Writing it in standard form, then we would have minus 12 plus 2i. So nothing new other than the fact that you're going to have to be careful about the I squared. The I squared, that we end up with a minus 12 there. Okay? But take a look at this. What if the multiplication happens to be such as this one? If you notice this multiplication right here, what we're doing is we're multiplying numbers that are conjugates of each other. Do you remember the word conjugates? You saw that before when you were binomials that are almost exactly alike except for the sign in the middle of each of the binomials. One is a minus, the other one is a plus. And so that should remind you that these are just the factors of the difference of two squares, such as a plus b times a minus b. And when you multiply a plus b times a minus b, you will end up with the square of the first number minus the square of the second number. Well, we'll use that procedure. Multiply then 3 minus 2i times 3 plus 2i, we should end up with the square of the first number minus the square. And you end up with these two terms right here. So we end up with 9 minus 4i squared. Once again, the I squared is minus 1. 9 plus 4. So notice that when we multiply two numbers that are conjugates of each other, what we end up with is a real number. We don't have an imaginary part to that number. That will become important when we do division. So in this case, multiplying 3 minus 2i times 3 plus 2i, we end up, which is the number 13.